So as Gary mentioned, this is Docker for PHP developers. My name is Chris Tankersley. Let's go ahead and get started kind of right away. This is a very long-winded blurb from Docker's website, or at least it used to be up there, about what exactly is Docker. There's a lot of different things that people talk about when they talk about containerization, and especially Docker itself. But there's a few key phrases in here that really kind of define what Docker is. So the first sentence, Docker is an open platform for developers and sysadmins to build, ship, and run distributed applications. And that's kind of the heart of what Docker is. It's going to allow us to get a much finer grained control over what we're shipping out to clients and to our servers, as well as much greater control on scaling up and running these distributed applications. Docker itself has many different pieces, as it alludes to here, but it also enables us to assemble components very quickly and, in very nice fluffy marketing speak, eliminate the friction between development, QA, and production environments. We can very quickly grab pre-assembled containers, put them together for our applications, and have the knowledge that when we work on something locally, it's going to be the exact same thing in production. So containers are going to allow us to start to get away from the it works on my machine problem from the very beginning and push it on up. But let's look at everything that we can do with Docker. First, let's talk a little bit about exactly what containers themselves are. So most people, even today, are probably doing some sort of bare metal deployments, even if it's to a service like AWS or DigitalOcean. We do this kind of bare metal server rollout. If you're lucky enough to still have servers, this will look pretty standard. We have a physical machine with some amount of hardware, CPU, RAM, hard drive, and on that we'll install an operating system. And inside that operating system, we will install all of our different applications. So we might install Nginx, PHP, a database server. But each of those applications is going to talk directly to an operating system, and that operating system is going to talk directly to the underlying hardware. There's a huge performance benefit to this because there's no real overhead other than the applications that are running. And this has been the standard for a very, very long time. What ends up happening, though, is over time, as computers have grown, we are ending up with many idle resources because we are just purchasing larger and larger servers, because it's no longer a day where we're buying a server with a 300 megahertz processor and we have to squeeze every ounce of performance out of that for just a single application. We're buying these huge multi-core machines. So virtualization allows us to take these big giant machines we're buying and using and use those more efficiently. So where we're only using a quarter of the RAM for a single application, we can then turn around and install multiple operating systems inside of a single machine and use more of the resources more of the time. So in a traditional virtual machine setup, at the very bottom, we still have the hardware and the operating system. Usually it's a very thin operating system, like just a very base install of Linux, or maybe just a few key components of Windows. But then there's going to be this hypervisor layer. This hypervisor layer is the glue between the virtualized systems and the underlying hardware. And this, again, is usually pretty lightweight, but it's there providing a gateway to the actual server, the actual hardware. And inside there in the little red boxes, we've got individual operating systems. So we've taken this bare metal setup that we had before and wedged it into those little red boxes. This works pretty well. We're going to get more machines running in total because we might be able to put 4 or 5 different systems inside of a physical machine. And again, this is something that we take for granted now. AWS has an entire system built on this that has been running for many, many years, that has thousands, if not millions of users. And it works pretty well. The only downside to it is it's kind of top heavy. So we have, in this image here, we have 3 operating systems running. We have the host operating system, and then we have 2 virtualized operating systems. Each of those operating systems takes up system resources. So if our base installation of, let's say we're virtualizing Windows, requires at least a gig of RAM, we have to make sure that that operating system itself has a gig of RAM that's eating up our resources. And then each process in there, of course, takes up its own amount of resources, just like it did before. The other problem we have is there's a lot of slowdown as you actually try to do very heavy I/O. So as PHP tries to read files from disk, it has to talk to the virtualized operating system. The virtualized operating system has to talk to the hypervisor. The hypervisor has to talk to the underlying operating system, and then you get to the hard drive. Before, we could just have the PHP instance talk to the operating system and pull it straight off the hard drive. Now we have to go through these multiple layers. So we get a little bit of slowdown. Most of the time this is fine, except for when we have really heavy I/O, and then we really start to notice it. Or you have a bad neighbor on the machine that's tying up the hard drives. But this is pretty standard and it works really, really well. The only problem is you're wasting a lot of resources and there are some performance hits. What containers allow us to do is kind of get a good cross-section of both the bare metal setup and the virtualized segregation. So what we can do is have the kind of the same setup as a bare metal server, have the hardware at the bottom and an operating system. But then we can start to contain or isolate processes. Part of this isolation is also being able to snapshot their running environment. So here we have 4 containerized applications. We have a traditional web stack with Nginx PHP and a database server. And then we have individual Nginx PHP and DB containers. So they are, much like the virtual machine, they're off in their own little world, but they have much less overhead. We don't have individual operating systems running inside of these, even though the one with all 3 processes may be running in what looks like an Ubuntu environment and the rest of them running in a CentOS environment. There is no virtualized operating system. The container system talks to the host operating system for all of the pass-through, and it works really, really well. This enables us to be able to scale up and down, as well as get much more performance out of a single machine, because where before we could only run X number of virtual machines with the operating systems, since there is no more operating system anymore to be virtualized, those resources are freed up and we can run more containers. So we are getting some of the benefits of virtual machines, which are being able to utilize the full resource of a large machine, but we're also getting much more of the performance of a bare metal server in that we don't have to go through these multiple layers just to talk to hardware. So containers are going to allow us to scale up and down, package our stuff, but we're also going to get a huge performance benefit out of this. Containerization is not new. Docker itself, which is a wrapper around containers, is new, but this is not something that is new. For many years, the BSD operating system, a Unix-like operating system, has had BSD jails, which allow you to section off a process. Regular Linux, many people have probably used chroot. Our PHP FPM container, or PHP FPM process actually supports chroot by default. Solaris has had zones for many years. So this is not a new technology. What has happened is Docker has been able to make it much easier to work with, much like how Vagrant was able to make virtualization much easier to work with. And Docker itself is an ecosystem. At its heart, we have the Docker engine. This is the piece that actually is the wrapper. You can think of this as Vagrant. This is the wrapper around whatever containerization technology you use. It's going to manage the packaging of the containers, the running of the containers, all that kind of stuff. But there's much more to it than just the engine now. 3 other main pieces have popped up as part of the official Docker stack. One of those is Docker Machine, and that's a process that will let us actually provision machines on demand. You can point it at DigitalOcean, and it will start up a virtual machine in DigitalOcean's infrastructure, install Docker, and make it so that it's available from your PC. Docker-compose is an orchestration setup. Most of our applications are not just a single process. They're not just a PHP FPM container. Most of the time we need a web server. We need to have the PHP interpreter itself. We may have MySQL and Memcache. Docker Compose allows you to make sure that all of the pieces of your application come up in a sane order and repeatable order and work together. Docker Swarm is Docker's built-in clustering solution, which in the newest version announced last week, I believe it was, is getting some major improvements along with Docker Compose. So at its heart, though, Swarm allows you to take multiple machines running Docker, easily join them into a cluster, and start to distribute your application without the need for for a lot of extra software. It works really, really well. And when you take the whole ecosystem into account, it makes working with containers and deploying your application much, much nicer. So exactly how does it work? Well, if you're on Linux, it actually uses technology from Linux. Docker and most of the container systems are natively built for Linux, and the way it does the process isolation is a part of the Linux kernel. So if you're on Linux, it actually runs natively. You just kind of pick a container technology or let Docker use the default one. On other operating systems that are not Linux, you need to either run it inside of a virtual machine or make sure that everything is set up to work properly. In Windows, if you're running Server 2016, they actually have a system called Server Containers, which provides a kernel-like interface that they have designed to work with containers directly. If you're not running Server 2016, they have a Hyper-V layer where they will run a virtualized Linux environment and then run your containers in there. And if you're running at least OS X Yosemite and obviously El Capitan as well, they have ported a virtualization stack called Xhive from the BSD project. On BSD, it's called Beehive. So now OS X has a virtualization layer, much like Windows has Hyper-V. So on OS X 10.10 or 10.11, it will run a small virtualized environment as well to run all of your containers. But the key is, for the most part, you're going to be in some sort of Linux system, be it bare metal or virtualized. But Docker does now support multiple distributions of Linux. It supports Windows 10 Professional and higher, as well as, like I said, Windows Server 2016, and then OS X 10.10 or higher. If you're on older versions of OS X or you're on Windows 10 Home Edition or older versions of Windows, they do still make available Docker Toolbox, which is basically the same thing, but instead of it using the Hyper-V or the Xhive virtualization layer, it uses VirtualBox. There are some little issues with host mounting and slowdown issues, which if you've run Vagrant, they're basically the same kind of problems. But if you want to try using Docker on older operating systems, you can download Docker Toolbox from Docker's website and be able to get up and running. And I should also mention all of the other than the Linux stuff, the Windows and OS X stuff is still considered beta status, but it's been in beta for a while and is getting pretty stable. So let's actually take a look at using Docker. The command you're going to be running the most is probably Docker run. This will create and start up a container for you. It will not restart an existing container though. So if you need to stop a container and turn it back on, there is a specific Docker start command. But for the most part, you're going to do Docker run to bring a container up, let it do its thing, and then it will disappear after some time. The format of the command is a little bit confusing. There's a lot of pieces here, but it's broken down into some pretty basic chunks. We have Docker run as the main command, and then after that, we will specify some options to modify the Docker process. So we may tell it expose this port, mount these files from the host operating system, link to another container. But after Docker run, we're going to specify Docker-specific options. Then we'll give it an image name to use, and this could be PHP, this could be MySQL, this could be Ubuntu, but this will be the actual image we want to use, and Docker will go grab that from the internet or use an existing copy. After the image name, you can specify a command inside the container to run. Most images have a default command, but you can specify a command. And then you can pass any extra arguments to the command that you want to run inside the container on there. So what you can't do is put your Docker stuff after the image name, because it's going to try to shove it into the container and run it there. So there's a lot of pieces on here, but once you've used it a couple times, you get in the pretty good habit of knowing where the different pieces need to go. So let's run a really basic shell. We're just going to run Ubuntu and run a bash shell inside there. So on my machine, I'm going to run docker run --rm, which tells Docker to remove this container once it's done. -I and -t tell it to run in interactive mode and to set up a TTY, so that way I can actually type in the container and get it to work. And then we're going to run /bin/bash inside that Ubuntu container. So once it's all done, it's going to download a file. So that's what all those pull completes are. Docker has an interesting way of putting together its containers to make it easier to download and share. So each container, you'll notice, is actually made up of multiple layers, and those layers can be shared between different containers to make it easier for you to download. So once you've downloaded Ubuntu once, you're not going to have to do it again. But then any images built off of the Ubuntu image can reuse the existing layers. But we can see here, once Docker is all set up and booted, my host name changes. So I went from ctankersley at Ubuntu to root at and then a hash. So that hash is the actual hash name of the container we're running. And I'm actually dropped into a shell inside that container. So I can run whatever commands I want. In this case, I'm just listing out the folders that are in there. But I could do anything I want. At this point, this is a full copy, full environment of Ubuntu that's not actually running. If I pulled down a CentOS image, it wouldn't actually be CentOS itself running, because all of this stuff is pushed up through whatever kernel I'm using. In my case, this was specifically Ubuntu. But if I'm running Arch Linux and I pull down an Ubuntu container, mostly it's the libraries from Ubuntu, and it uses the host kernel to actually run those applications. But here we can see I'm inside the new container, and the nice thing is, if I want to see what processes are running inside the container, I can only see what's inside that container. Part of Docker, and one of the nice things about it, is its process isolation. So once you start a container up, it can only see itself once that command starts. So bash, that I started inside the container, only sees bash and then the ps command I just ran before it. It doesn't see anything else that's running on the host. So from a security standpoint, this is kind of nice. If someone does get into a container, they're not going to be able to see what else is running on that computer. So it is a little bit of security through obscurity, but it does allow us to isolate these processes so they can't see the outside world. Now, let's take a look at actually running two different web servers. So what I'm going to do again is run docker run, and I'm going to do -d. -d tells it to run in the background. I'm going to give it a name with --name, so I'm going to call this one web1. And then I'm going to do -p, which tells the system to expose a port through the host. Much like with Vagrant, you'll expose the virtual machine port through the host port. So I should be able to go to localhost 8080, and it will pass that back to my container. And then I'm going to run the Nginx container. So again, we have the different sections here. We have docker run, the -d, the name, and the -p are all arguments for the Docker command, and then Nginx is our image name. So I've already pre-downloaded this image, so all we see is the hash of the container that starts. And then we're seeing a new command here called docker-ps. Docker-ps will list out all of the running containers for your system. So I can see here I've got one container running Nginx latest, and its name is web1. And we can see the port is exposed. So if I go to localhost :8080, that arrow signifies it's being transposed back to the container. So of course, if I go to localhost 8080, I'll get my welcome to Nginx site. And so everything is perfectly running inside that container. There is a docker exec command that you can run, and what that will do is that will start a second process inside an existing container. Normally containers are only going to do, and Docker is kind of designed to only run one process per container. If you need to start up multiple processes, you either have to jump through hoops when the system or when the container comes up, or you can use docker exec to kind of force start something inside of there. So I'm going to run bash inside my existing Web 1 container. I know it's available there because Nginx is built off of a full, I believe, the Ubuntu image. So I know bash is available. So I can run bash inside there by doing docker exec, again doing TI to give me a TTY and run interactively. And then Web 1 is the name I want to run it inside of, and then bash is the command. So we can see I go from, again, my host name to the hash of the image. So we can see if you look real closely, the root at and then that hash matches up to the beginning part of the image we pulled down at the top. So now I'm inside this container. I can go in and I can edit that file. So we're going to change that default page to hello world. And if I refresh my page, I get hello world. So now I've got a web server running that's actually serving actual content. But let's start up a second one. So we're going to do basically the same command, but we're going to name this one Web 2. And I'm going to expose its port 80 to 8081. Just like with Vagrant and any other process on a Unix system, you can only attach one program to a port. So since 8080 is already used, I'm going to use 8081. If I do docker ps again, now we can see I have two webs. I have Web 1 and Web 2, and they're both running Nginx. So big thing to look at here is they're both running Nginx. They're both running the same container or the same image. But if I go to 8081, it says welcome to Nginx. So when you start a container, it branches off into its own kind of lifespan. It'll use an existing image as a basis, but the system will keep the actual internals of that separate from that point on. So I can go in and modify one container without affecting another. So, and then if I stop them both, they both just stop. So one thing to take out of this is all three of these containers are self-contained. In that original bash example, if I had gone through and just deleted everything in that file, Docker doesn't care. It only trashes that one container. With the two web servers, just because they both share a common ancestry doesn't mean that they affect each other at all. I can change files in one, but leave the other one completely intact. And just for some notes for the Docker run parameters, --rm destroys the container once it exits. So we did that with the bash command because I just wanted to have that live for that little example. The web containers, we did not pass --rm. So when I stopped them, they are still physically on the machine and I can restart them at any time. -d tells it to run in the background, -i run in interactive. Again, for bash, since I need to be able to type in, we do the -i. For the web servers and Nginx itself, I don't need -i because I'm not doing anything interactively with Nginx. And you can give it names and you can give it ports with -p. So now that's all pretty good, but most of us have files we need to get inside of something and run it because we don't want to spend our time having to start a container and then exec in and then have to run Vim. I love Vim, but there are much better tools out there for doing day-to-day stuff. So let's talk about getting data into those containers. Like I said, we can run docker exec and we can go in and modify it, but that's a huge pain and doesn't really scale very well. The easiest thing to do is to use the built-in volume system to share data, and there's two ways we can share data with the system. One is to persist data with volumes inside of a container, or we can mount it directly from the host system. So in Docker, one of the options you can pass it is -v, and then either give it just an internal path, which will tell Docker to make sure that the path inside the container always never gets rebuilt. Or you can do -v with a host file path, a colon, and a container path, and it will mount the files from your host machine up into the container. So let's take a look at both of those. For development, a lot of times we're going to want to mount directly from the host machine. That way we can edit locally using something like PhpStorm and then just use the containers to kind of run the software. So here we have a folder called temp, and inside of it is two other folders, a config folder and a site folder. So inside the config folder is just a very small Nginx config file. And inside the site folder is a static file, and it just says from the host. So with the docker run command, it's basically the same web1 command we ran before, but we're going to use -v, and I'm using the pwd command to print out the folder path I'm in. So we're going to take the /site folder, mount that into var www inside the container, and then we're going to take my config folder and mount that into etc nginx conf.d inside the container. So now we're telling the system, take these from my computer and make these folder paths available inside the container. It doesn't copy them into the container. It just maps those folders in the container to the host. So since we've already run Nginx, we see we get a hash. And if I go to localhost 8080, we can see that I get the file from the host. So I don't have to go into the container to edit that file anymore. It's pulling it directly from my machine. I can go in and change the file, and if I refresh it again, we change the file. So this is a pretty standard setup for most developers, especially if they've been running Vagrant. You're going to have an external system running all of your processes, but we're going to take the files from our local machine and push them up. So now this isn't great for all purposes. The first big thing is the container now has a window into your host machine. If you're doing this on a production environment and you're allowing file uploads, in theory, someone could upload a malicious file to your server. It'll go through the container because it's uploaded through Nginx or whatever. But now it's physically sitting on your machine in a what's probably accessible area. So you have to be really careful about that. If you're running local development, permissions can get a little bit screwy. Most of the time, containers are running as root permissions inside the container. So when you upload files through Nginx or Apache, they may be saved with root user IDs and group IDs. So that may get a little bit weird. There are some options you can do to change what user a container runs as, but not all containers are compatible with that. So your mileage may vary, but it gets a little bit worse, especially if you have to use Docker toolbox, because now you're combating your host machine settings versus the virtual machine settings versus the container settings. The biggest downside to all of this is host-mounted volumes are not portable. Where I am running my local dev environment is probably different than your local dev environment, which is probably completely different from where production stores the files. So with host-mounted volumes, you have to specify a full path, and those full paths aren't going to match, so it makes it really hard, especially if you have a heterogeneous environment. You've got multiple machines running Docker. Their file path setups may be slightly different. So it works great for development, not so great for production. Once you get into production, you're probably going to want to look at data volumes. And what this is going to do is basically set up a container that does nothing but live there and store data. The container never actually runs. It just kind of carves out space so that you can store data inside of it and share it amongst containers. We can have that, like I said, we can have that data shared amongst the containers. So now I can have one data volume with my application data and then share that between Nginx and PHP. Generally, then what you'll need to do is have some sort of editor container to go in and modify that data because it's actually going to be inside of a container. It's not going to be host mounted from the machine. So let's kind of take a look at that. We can use Docker create to create an image without running it. So we're going to do kind of what we did before. We're going to create an image. We're going to use -v and tell the system inside this container, make sure that etc nginx comp.d is never destroyed when we stop and start. Same thing with var www. We're going to give it a name called web data, and I'm going to use the busybox image instead of Ubuntu or anything specific. Busybox is a very tiny image, but still allows us to go in, run things like bash, install extra files, things like that. So it gives us a nice little fallback, but busybox itself is not going to take up a lot of space. So there we can see a hash, so it was generated correctly. If I run docker ps, it doesn't show up because this web data container never runs. Docker create doesn't run a container, just takes an image and copies that into a container. If I run docker ps-a, which says show me all of my containers, we can see it show up there, but there is no status because it's not running, and it never has to run. We're using it just as a bucket to hold files. Now, if I start a editor container, I'm going to use a Ubuntu container to run bash again. But what I'm going to do now is specify -- volumes from. What that does is it tells Docker to take the volumes from an existing container, in this case web data, and overlay those into the new container. So now my etc nginx comp.d and my var www folder in my little Ubuntu container here is attached to the same data volume that web data is using. So now I get my shell, I can go in, I can install Vim, I can edit my configuration just like I did before. I can edit my application just like I did before, and save all that off, and it's saved off to the data container. Now I can build a web server. So I'm going to do kind of what we did before with the web servers. We're going to run it in the background. We're going to expose port 8080. But instead of me specifying folders on the local machine, I'm going to use -- volumes from and specify web data. So now Nginx, instead of it taking files from my machine, are going to take it from that data volume, overlay them in, and then it's going to work. So if I go to localhost 8080, I'll get from the volume. So now we're actually in there. We know we're pulling the data from that data volume. So why do you want to go through all this hassle? Data volumes are pretty portable. You can, Docker has a lot of stuff built in to pick up and move data volumes pretty easily. It's not quite hot swappable, but it makes it very easy to move it around. A lot of the deployment systems will actually go an extra step, and if you use tools on top of Docker like Rancher or other ones, it will make the data volumes available across multiple hosts. Data volumes are safer because everything's contained inside that data container. So if your Nginx container accidentally gets deleted, or you accidentally delete files off your machine, that's fine because everything's inside the data container. One big thing it does from an architectural standpoint is it separates the app container from data. So we can start to build much smaller, leaner production applications that run just what we need for production. So we can worry about just building Nginx. We can worry about just building PHP without having to package up our full application file set in there as well. So it makes our app containers very small. And then once we separate that out, our production data, our production images can use the data volumes, and our dev environments can use the host volumes. So that way we get a pretty traditional setup. Again, I can edit locally using PhpStorm, and then when I push it up, everything will live off of data containers. So volumes are nice, we can share those, but a lot of times our containers are going to have to talk to each other in some way, especially in our case if you're running PHP FPM, you have to have Nginx or Apache talk back to PHP FPM. And because we're isolating processes, you can't do that via a socket. We have to do that over a network. Same thing with like our database servers. Generally, we want to talk to them over a network connection instead of a socket now. So Docker has a linking mechanism that basically allows containers to see each other over the network. In a discoverable fashion. You can start a PHP container and then let Nginx know that it exists, and then Nginx can reference it via an actual host name instead of having to know what the real IP address is. Docker actually sets up a network on each node that it's on. So all of your containers are running in a network. My containers happen to run in a 172.17 address space, where my host machine is running 192.168. But if I stop a container and restart it, it's not necessarily going to get the same IP address back. So linking allows Docker to keep all of that in concert. And then what we can also do is not have to expose everything through the host. So I've been exposing port 80 through port 8080 just for ease of use. So that way I can go to localhost :8080 and it passes it through. But if I have a memcache server running, I don't necessarily want that exposed to the world unless I want to jump through the hoops of securing that down. But if I run the container locally, you can only see it from the machine. So we can use these links to our advantage to, one, provide an extra kind of firewall layer between the services we want to run in the outside world, but also make them talk. So in a pretty traditional setup, we'll have the interwebs, and then we will have Nginx, and that's going to talk to PHP FPM over port 9000. So we're going to replicate this in Docker. So to do this, we're going to set up a data volume. That way we could have an Nginx container and a PHP FPM container. They're both going to talk to that. So just like we were doing the data volume mounting before, we're going to do that here. And then if we need to change anything, we will go into an editor container and edit it that way. So we'll create our web container like we did before. And what I'm going to do this time is I'm going to go in and use a containerized application. In this case, someone has made available Vim as an editor container. So I can go in, mount the volumes from web data, pull them into a pre-built Vim environment, and run it in there. So I will edit 3 files. I will edit index.php, I will edit static.html, and I will edit our default.conf. So just kind of like we did before. What I'm going to do this time, though, is I'm going to specify a fast CGI pass-through server. So I'm going to say whenever you get a PHP request, pass this off to some machine on the network called PHP server over port 9000. In a minute, we'll define exactly who PHP server is, but I can go through and set these up. Where this becomes really powerful is you can have an entire cluster of these set up through Nginx and use like round robin or whatever to have your Nginx container talk to multiple PHP FPMs. But for now, we're going to talk to just a single server called PHP server. Then we're going to go ahead and start a PHP FPM container, which is a little bit different than what we've been doing. So now we're getting into multi-tiered applications. So I've got pretty much the same basic Docker run command. We're going to do Docker run -d. We're going to name it web PHP. We're going to pull the volumes from web data and throw that into a PHP FPM container. So nothing really special here compared to what we've been doing. It starts up and it runs, pulling the files from our web data container. Then we're going to go through and we are going to run a web server. So we're going to name this web server. We're going to pull the volumes from web data like we did before. What we're going to do this time, though, is we're going to add a -- link. What this does is it says link a container as a specified alias inside this new container. So we're going to build an Nginx container. We're going to link web_PHP, which is the PHP container we just created, but we're going to call it PHP_server inside the Nginx container. So Nginx, whenever it says talk to PHP_server, Docker is going to forward all of that network traffic to web_PHP. So then if I go to the address of my Nginx container, 172.17.0.62 in this case, it automatically runs index.php, notices its PHP file, passes it back to the FPM container over port 9000, and then runs it. So that's a pretty traditional PHP setup for us. So we have a web data container containing all of our files. We have a FPM container running PHP itself, and we have Nginx running. You will notice I did not do -p:8080 on here. Just that way I can just go straight to the container box and have it work. So we can rebuild sections of the app as we need now that we've got it separated out. If I want to try a different version of PHP, I can just swap out the running container, relink it, and everything's good. If I need to restart Nginx, I can restart that without impacting PHP at all. And if we need to scale, we can scale appropriately. If we have a lot of heavy PHP processes, and that's where our bottleneck is, we can spin up more PHP processes without having to spin up extra Nginx processes. If we have a pretty static site with just a little bit of PHP, we can spin up extra Nginx containers to handle all the static content and leave our PHP containers alone. There's a whole lot of stuff that was added in Docker 1.12 that's going to be coming down the pipe, especially with the network linking and the volumes. So that's a lot to cover. So if you are interested in this and some of the clustering stuff they're adding, check out Docker 1.12. It's in beta right now. Hopefully it will be released soon. But there's a whole lot of stuff that's going to impact how this works. But if you're running Docker 1.10 or 1.11, this is going to be the traditional setup. And this will still work in 1.12. 1.12 is just adding some new stuff on top of it. So now the images that we've been using have been pre-built by Docker and are official images. But there will come a time when you have to build your own image. The failing of the stock PHP image is that it does not contain very many extensions. It's even so bare as there's no database connections in it. So we're going to have to create our own. Docker has a way to do this through a thing called a Dockerfile, and you can either create one completely from scratch or base it off of another image. So many times what I will do is I will start with the base PHP image, have a couple commands to install the extensions that I need, and then it's all good to go. So these aren't have to be huge, complicated files. The Dockerfile is going to allow you to add files, install things inside the system, create default volumes, expose ports automatically. Pretty much anything you could do on the Docker command line, you can tell the Dockerfile to set up by default. Once you've built an image, you can either use it privately on your local machine you built it on, push it up to a private repository, or push it up to Docker Hub as both a private image or a public image, depending on what you want to do with it. So this is a sample PHP 7 one that I have for an application. So what we will do is most of them will start with a from command, and it can be from scratch, which means where there's nothing at all in here, or off of an existing one. So this is going to build off of the PHP 7 image. I'm going to run a command, so I'm going to update apt, and I'm going to install a couple dependencies, and then I'm going to install the iconv, the mcrypt, the PDO, and the PDO MySQL extension. Like I said, the PHP image, no matter kind of which version you use, doesn't have many extensions. So if I need to be able to talk to MySQL, I need to build a Dockerfile that does that for me. For the most part, the top half of it's going to be a lot of shell commands. So here we've got Docker apt-get update and apt-get install and Docker PHP extension install. So you'll have a whole bunch of those. Then anything you need to set up your application. So I'm going to take the built part of our application. So this may be something that's gone through, for example, Bamboo, and it's had Composer run on it, and it's had Bower run on it, and NPM. So all the pieces are run and built. We're going to take that compiled application and put it in var www. So now whenever we go to build this container, we'll put our application inside of it. We'll expose port 80 and 443 because this also this is taken from an Nginx container, but we can see some of the other commands we've got here. So we can expose the ports for it. Normally for this we would expose 9,000, but we can specify multiple ports here. We have volumes automatically set up for var www and var log. That way, if I stop and start the container, those files will persist. And then at the end, I'm going to do some cleanup, just another command. But basically, it's a skeleton for how you want this thing built. and it can be a little bit long like this, or it could just be enough to copy your files in. One Dockerfile I have is 2 lines. It's from Nginx, and it's copy output dev to var www. That's it. And we use that to deploy with. So, but you can go in, start to build your own specific file, and use exactly what you need. Once you have the Docker file in place, we just need to tell Docker to build it. There is a Docker build command. So you do docker build -t, give it a name. In this case, it could be my app :latest, whatever, and then point it to the folder containing the Docker file. If the Docker file is in the folder you're in, you can use // but you can point it to an arbitrary folder as long as that folder has a Docker file in it. A couple other helpful commands. You can use docker inspect and a container name to get back a JSON blob of all the information about a container. This is really useful if you're building your own management software or reporting software. I use it all the time to get the IP address of a server. If you want to get a specific key, you can use -f and specify a namespace inside, or a key inside the JSON. So if I do -f .networksettings.ip address, I'll get back the IP address of my server. But I use it a lot for scripting things. If I have I actually have a small little script that when I bring a container online, it will get the IP address and a couple other bits of information and push that into a reverse proxy setup. So now all of a sudden, the reverse proxy can properly route stuff back to the new container. If you want to work with just the straight images, you can use Docker pull to download an image without using it. You can see what images you have installed with Docker images. And if you ever need to get rid of one, for example, you're not using it anymore, you can use Docker RMI and then an image name, and that'll completely remove the image. So real quickly, Docker machine. Like I said, on Linux, you install a couple packages, it works. For the most part, though, a lot of us are going to be working with Docker on a remote computer, mostly because, if nothing else, production and staging are not our physical machines. What Docker machine will do is it will provision a machine and install Docker. So I use it a lot, like I said, with DigitalOcean or AWS to specify, here's the virtual machine type I want. It goes and installs that and then installs Docker inside of it. I can also use it to automatically add it to a Docker swarm if I'm doing that. But it's a really nice way to very quickly bring stuff up. If you use Docker Toolbox, it actually uses Docker machine to create the virtual machine that Docker Toolbox uses. So that's really handy if you need to go in and fix it. And it supports a whole bunch of services. So like I said, I use DigitalOcean and AWS. It supports Microsoft Azure, Hyper-V, OpenStack, VirtualBox, which is what Docker Toolbox uses, even supports various VMware setups. So you can build Docker machines against a wide array of backends. So one reason you may want to use it is to easily spin up new boxes. I've been working on a new project lately. So what I will do is I will use Docker machine to spin up a box, deploy code to it, make sure it works in DigitalOcean, and then when I'm done, destroy the box. So I can use DigitalOcean kind of in a scripted AWS manner very easily, and know that whatever Docker stuff I push to it, it works fine. Docker machine is going to handle all that dirty stuff for you for installing Docker. I use Arch Linux, so I have to download a slightly different install package than it does for Ubuntu than it does for CentOS. So Docker machine handles all of that. If you're using Docker Toolbox, it's already there. And the real big reason, especially now, is it integrates with Docker Swarm. So you can use Docker machine to build a machine and automatically join it to a Swarm node. So if you need five new machines in your cluster, run Docker machine and just have them automatically attach. The only kind of downside is it's not necessarily portable. So if I use Docker machine to provision a machine from my laptop, for anyone else on my team to be able to access that automatically, I need to copy those config files to their computers. So it's not something where there is a central management that you can do this with. Docker Swarm, like I said, is the clustering technology. Up until Docker 1.0, 1.12, it's kind of bare bones, and it requires a lot of extra stuff to get it to kind of work in concert nicely. 1.12 is going to change a whole lot of that, so there's not a whole lot I can definitively show right here because it's very much in flux. But what Swarm basically does is it provides an API-compatible interface to a cluster of nodes, just like as if you were working with a local Docker machine. So I can run Docker PS, I can run Docker run, all that stuff. And Swarm will handle provisioning those boxes out on those machines automatically. The Docker team has a really neat visualization on spinning up 1,000 containers at once and how quickly it's able to do that. Docker Compose is one thing you're going to use quite heavily, especially in the development environment. So like I said, this is multi-container orchestration. So in just our little sample app, we have Nginx and PHP. A real application is also going to throw databases in there. Docker Compose is going to be able to give us a single configuration file that defines each of those containers and how we want them to work together. I would heavily look at Docker Compose. It works directly with Docker Swarm, and a few other tools use it as well, like Rancher. So your deployment may be as simple as building a Docker Compose file and using Docker locally, and then pushing that into a management system like Rancher that knows how to build and maintain a whole bunch of servers. This is a real quick sample Docker Compose file. So I've got 3 containers defined here, a PHP server, a MySQL server, and Nginx. You can either have these images built from a Dockerfile or from a base image. So the PHP server and the Nginx servers are going to use custom Docker files. One is located in docker/PHP and the other one's in Docker Nginx. The MySQL server, however, is going to be just a straight MySQL container directly from the Docker Hub. I can specify volumes. You can either specify a full path or a relative path. So I'm going to take this folder and I'm going to mount it to var www inside the PHP server. And then I'm going to specify links as well. So I want my PHP server to be linked to MySQL, and I want my Nginx server to be linked to PHP. So Docker Compose, instead of us having to manually run Docker run commands for everything and make sure we do stuff in the right order, Docker Compose will bring them up in the right order, link everything together, mount all the files, and have all of it work really, really well. The other cool thing is if you have a Docker machine set up, you can run Docker Compose against a remote machine, and it will take all of the stuff, build it, and run it in the remote machine. So all of these tools are starting to work in orchestration. So now when it comes to PhpStorm, PhpStorm does have a Docker plugin that you can use. So I apologize, my local machine is not working very well with the screencasting software. But if you want to install it, go into the settings pane for DockerStorm or for PhpStorm, and then go to the plugins option, and you can search for the Docker integration plugin. You can install that, restart. PhpStorm takes just a few seconds. And then you'll get a new configuration option in the settings called Docker. You'll have Docker and Docker registry. Go into the Docker settings and add a new Docker server. The settings are pretty smart. If you're using OS X or Windows, it tends to auto-detect the settings. I'm using Linux in this case, so I just point it to the Docker socket. But it'll pull all the information in. Create that server, and it's kind of like a remote PHP server and stuff like that. So fill that in. Now we can actually use this to deploy against. Down at the bottom of your editor, you'll get a little Docker tab. If you click that, you can connect to your Docker instance and start to work with it. So here I've got my local Docker instance. You can see all the images I have installed. And right now I'm not running anything at all, so the containers option is empty. We can download an image, so that way if we're going to use PHP 7 for our system, we can download that. When you click on the download, the pull image button, you tell it the name you want to pull down and the tag. So by default, it's going to pull from Docker Hub, but you can add in custom registries. I'm going to pull from the PHP repository, and I'm going to pull the 7-PHP tag. So it's going to pull that down from Docker image. It just takes a couple minutes. Once that's done, we can deploy a project by clicking on the deploy button. If you have a Docker Compose file or a Docker file, Docker will usually auto-find that and suggest you set it up. Or you can specify an exact image. Here I'm going to specify run this in PHP 7 Apache. I'm going to call it my app. And then it's going to use my local Docker server. I can also go in and specify host mount volumes. So I'm going to take my local project here, and I'm going to mount that to var www HTML. You can specify read-only. You can also do linking, port bindings, all that stuff. Most of the Docker run commands are available through this container tab. Once that's done, you click run, and it will deploy the application. You'll get another pop-up on the side with a whole bunch of information. One is the deploy log, which is what PhpStorm does to launch the container. You can see the log, all the output of the container, various information about it. But the thing is, now we've actually got this running, and we can go and start working with it. So if I go to the IP address 172.17.02, because that's what it was on my machine at that time, and run it, I get my PHP 7, my PHP info pop up, because that's all that was in my file. So that's really all it takes to get Docker working directly with PhpStorm. So far, the plugin's been very, very nice. So you can go in and start working that directly with your IDE. The current version that I've been using, it supports Docker Compose files as deployments, but it doesn't support custom Docker Compose settings files. So Docker Compose, one thing you can do is layer multiple Compose files on top of each other. It doesn't support that, but it will support Docker Compose files out of the box. So that's really all I have for right now. So thank you for attending this presentation, and I hope you enjoyed it. I have a couple projects up on GitHub if you're interested in that. As Gary said, I am the author of Docker for Developers, which you can find at leanpub.com/dockerfordevs. If you want some more in-depth information about everything I've talked about, you can find me at ctankersley.com. If you have any questions, you can feel free to email me at chris@ctankersley.com or find me on Twitter at DragonManTank. I announce a lot of the Docker stuff, and soon I'll be announcing a new project, probably today or tomorrow. So if you're interested in Docker and you want some more information, follow me, pick up the book, all that kind of stuff. But with that, if we have time for questions, I can answer those. Otherwise, I will hand this back off to Gary.
Thank you very much, Chris. Yeah, I must remember to unmute my microphone before trying to speak. So we have a couple of questions. If you can just be kind of fairly
Sure.
Fairly quick with the answers, but these are ones that caught my eye and were interesting to me. So is there a way to specify the resources, like the memory amount that the container uses?
There is from the command line, so you can enforce quotas and that kind of stuff from the command line and the Dockerfile and Docker Compose. I don't know that you can do it directly through PhpStorm, but you can impose CPU and RAM quotas.
Thank you very much. And did you see an improvement in Disk.io with Docker for Mac? Now, that's probably not a great question for you, although I know you do use a Mac now and again. So
yes. Unofficially, I have seen a bit of improvement, though that's taking into account VirtualBox's I/O is pretty slow to begin with. It's not quite as on par as the native stuff, but it is better. I think from the people I know that have been using on Windows, it is much improved on Windows.
Okay, cool. And this is an interesting question. How granular should we get with the images? If I want to switch between PHP versions, should I install Composer, PHP Unit, WP, CLI, etc. in each of those images, or have separate images with those apps that can be kind of made available to the image that's running PHP? I guess image means container there.
Right. It kind of depends. I usually don't install ancillary software inside the images. So if I have a PHP 7 container, that's it. I will build a separate Composer container and a separate PHP unit container to handle all of that. Or if I have everything pulled in through Composer, I will just run the PHP command through the container to run PHP unit. So I might use the same container, but use the PHP CLI version to run the version pulled in from Composer. I don't usually specifically install those things inside there as a global option.
Okay, cool. So we've got like another sort of minute or so I'll just run through some of these quickly. What's the best practice to change files on the data source files container?
Most of the time, if you can manually edit it, that's one way of doing it. Most of the time, what I will do is I will deploy a new version of that container. So I'll have a Dockerfile that will build it, package my application up into there, and then shove it off. Cool.
And the only other question I wanted, which is a little bit specific, but it did catch my eye, was are container links legacy by now? As far as I know, Docker networks would be a better practice way to allow communication between containers.
If you can use the Docker networks, that's the best option. A lot of places, they're not upgrading straight to 11 or 12. So I think Ubuntu still ships with, I think maybe even actually 109. So it's useful to know because it's going to probably impact your production environment.
And obviously,
whatever the current version of that is. So
it's worth mentioning that when we do deliver webinars that are an introduction to topic, we often will show the simplest way rather than the sort of more cutting edge way. So yeah, it's all good. Thank you very much, Chris. That pretty much answers the questions. Thank you to everyone. So if I can just take back the screen here. Just a little tiny bit more information. Yes, download PhpStorm, learn more about PhpStorm at jetbrains.com/PhpStorm. Please give us any feedback. You can tweet at myself directly at GWH, or you can tweet at PhpStorm with your feedback. Many people ask questions during the webinar. The recording will be available and it'll be available on our YouTube channel, which is youtube.com/JetBrainsTV. We'll tweet when this video goes up. Typically, they get released fairly quickly within a few days of completion. So keep your eye on our Twitter account to find out when that goes up. And yeah, follow us on Twitter. We'll be blogging about the upcoming release. So we do have a release planned for next month. It's a major release, 2016.2. We've got some amazing features, if I do say so myself, stuff that I'm really excited about as a PHP developer. My particular favorites at the moment is the PHP 7 support has really stepped up a level with kind of static inspection of return type hints and scalar type hints, which is kind of awesome. And we've got some Docker improvements coming in upcoming major and minor versions. And I would have liked to have demonstrated the plugin for PhpStorm live, as it were, but we will get some video content out in the coming weeks and months to show how this works, the Docker plugin and Docker. So thank you very much for joining us for this webinar. Yeah, as I say, please do let us know what you thought, and we'll catch you at the next one. Thank you very much.